Hello, everybody, and thank you for being here. My name is Luca Giovannini, and I work for DataNext, which is a company that mainly works in building software and application for local public administration. And those applications mainly are involved in digital transition and in supporting policies, social and green policies. But why am I here in a free software conference? Because my company also supports open software through participation into European projects, European-funded projects. And I'm here to present you one of those projects, that is Usage. That has the aim to provide open data and open solutions, open software solutions, to support city administration in their environmental policies, in the implementation of their environmental policies. And that through the FAIR principles, so providing data and solutions in a findable, accessible, interoperable, and reusable way. So, what are the main outcomes of these projects? The first one is related to a document. It's the creation of a governance framework for the city of Ferrara. We were piloting this project. We were supporting the piloting of this project in the Italian city of Ferrara. And what is this document? It's an agreement between major local players, public bodies and private companies, that agreed to share data with one another in a simplified and secure way, which is a major result if you know a little about how difficult it is to exchange data between local actors. So I have a pointer, yes. Basically, you have, of course, the municipality of Ferrara, the regional administration, the regional agency for environmental protection, and one of the major energy and water providers, and also waste management provider for the area. I maybe forgot to mention that the project was about environmental support, so that's why those were the main actors. And the outcome of this agreement is, among the other thing, that the data should be shared through open and standard web services. So that was the major result from my point of view and relevant here. Second main outcome is the increase in availability of data, of open data set to support, again, the development of local policies. So that was the major aim, but since they are open, then every citizen has access to them. And when I say increase in number of data available, I mean more than 200 new dataset, mainly geographical dataset, that were made available through the municipal data portal. And just some example of those datasets. For example, thermal images derived from satellite. Those were already open data. We are talking about here Landsat data, but they were elaborated to provide information about heat islands, so locations where during the summer the city is really hot. Then also more detailed thermal images from aerial flights. Of course, they are more detailed, but they are available just for the time and day when the flight was executed. So there was one flight during the day, and one flight during the night. What you see are images of the data that are provided through a public web portal, but the dataset itself is also, of course, available. Then hyperspectral images that were used to derive other types of data. We shall see them. Then also LiDAR flights that are used to create digital models of the ground. So 1 meter resolution data set describing the surface, so rooftops, trees, roads, and all the elements of the surface in almost all the municipal area. And from the hyperspectral data, through the machine learning algorithms, were identified the location of trees, so both in public spaces and in private areas, to have a clear idea of the situation about availability of trees in the city, so their location, the extent of the crowns, and also the species was derived by the signature, through the hyperspectral signature. Then again, one of the other data sets that were derived from those flights was an estimation of the materials of the surface. So through this it was possible to identify roofs that were made by dangerous materials. So that was also very useful. And then part of the project were 3 citizen science activities that again created data that was made public. So about this census of biodiversity, local biodiversity. So people went around identifying plants and animals. Then also tools to do crowd mapping of floods was set up, and also campaigns to measure air temperature through the sensors were set up. And all the data is available through the web portal. Then the last outcome, which is probably the most relevant here, is the fact that we set up a GitHub page where we put all the software that was developed in the project, not just by DataNext, but also the other partners of the project, available to everyone. They are not full application with an interface, with a user interface. They are mainly algorithms, so Python scripts or scripts in other languages, but nevertheless they are open and they are useful to derive all the things that I've showed you. And again, those are further examples. There's the algorithm that derives heat islands from Landsat data. So basically here the work is to go from what the satellite actually measured to an estimation of the temperature on the ground. That's the added value. And then about roofs, there are a couple of pieces of software that identify where roofs are, what's their inclination, and what's the potential to gather energy from the sun, depending on their inclination and orientation. And also another tool that identifies if there's already some solar panel installed on the roofs. So you can combine those to derive the actual potential of some areas if they were equipped with solar panels. So taking out the roofs that are already equipped and estimating what you can get from the ones that are not. And if you also have additional information like Ferrara had about which roofs couldn't be used to install solar panels because they were in historical areas or for other reasons, then you can really use these tools to derive quite an accurate estimation. And then, as a last example, the data was used to derive a livability index related to how much green areas you have close to each home. So how close is the closest park? How many trees do you have in the next to your home, and how many trees do you see from your windows? And that gives this index that has the level of detail of the single household. And that's again the way to derive it is freely available, openly available, and also free, of course, from that GitHub page. And I think that concludes the presentation.
Thank you very much, Luca, for your contribution. Are there any questions from the crowd?
Hi.
Hello.
So you mentioned that you used OCZ, Open Geospatial Consortium standard, OGC,
Yes.
OGC standards. But does that extend also to an API to access the data, or?
Yes, mainly in this project, it translates into providing through a web portal access to data via OGC web services, so WFS, WMS, WCS. Basically, that's it in this case. So it's standard APIs to access to raster data, vector data, and
Okay.
through the portal of the municipality.
Okay, and maybe just a second question.
Sure.
Did you try to use any kind of ontology or kind of schema for the data that trying to map all of them to a common
Yes,
schema?
I'm not the one who worked specifically on that, but of course, for the specifically for the data for example, for the data collected in the citizen science campaign about plants and animals, that followed a standard schema coming from people that work in the field of plants and animals. So I can ask to my colleagues for the specific schema. And in general, for dataset related to sensor measurements, so for example, the one about the temperature measurement, we made them available through the sensor server of the municipality of Ferrara, which follow another standard, which is Sensor Things API.
Oh, Sensor Things, yes, of course.
Yeah.
That was,
So
I know this one. Perfect, okay.
That's the one that I can recall, but we can have a further chat later if you want.
Thank you, thanks a lot.
You're welcome.